Hello, this is Mike Thompson speaking from Tacoma, Washington. Thank you to everyone for taking the time to watch the video today. I hope you find this informative and entertaining. I've never done a video presentation like this, so we'll see how it goes. Before I get started, I need to give a special thanks to my friend Barbara Haynes, who gave me tremendous help in editing my paper and helping me organize how to present the ideas. So without further ado, the title of my paper is A Supplemental Tool for Reporting Technology Readiness Assessments. What I'm proposing here is a one-page addendum to the industry standard technology readiness assessment report, where I just provide more complete information than what you get in the standard industry tool. Quick bio on myself. I retired from Boeing in 2016. I spent the first 10 years of my career working interior materials and flammability. And then I transitioned over to structural composite part fabrication, where I led a wide variety of developmental projects. Basically, if there's a mistake to be made in project management, I've either made it myself or I've seen someone else make it. And so that's kind of the experience that I bring to this discussion today. On my project, I am kind of limiting the scope of my paper. My experience is in development and implementation of structural composite parts for aircraft, and that's what I know about. And I hope that some of these things that I'm going to talk about today would be applicable to other technologies, but I don't know enough about those other technologies to really claim that. So consider this discussion to be about composite part development for aircraft. So why do we need to assess technology maturity? You'll have a senior manager will oversee 25 or 50 or 100 projects, and he doesn't have time to read 50-page reports on all the status of all the projects. He's got to have something that's going to tell him in a matter of seconds where a project is, because he's got to decide what he's going to do in his factory for the next year, 2 years, 3 years in terms of facilities to purchase, equipment, laying out people, space, etc. And so he's got to know which technologies are ready for implementation in the near term versus the far term, and then where the funding needs to go. So it's a tool that basically facilitates future planning for senior managers. Now, in composites development, we generally work it according to what they call the building block approach. And the principle of the building block approach is you don't want to be building a 30-foot long part that costs hundreds of thousands of dollars and be experimenting on it, because that's just cost prohibitive. So what we do is we build lots and lots of flat coupons we can build these fast and cheap, and we generate all the data that we can on our material and our process with these flat coupons. Then we roll that data up to slightly more complicated elements that will have some contour and some design features. And then that data gets rolled up into details. And basically, we will have figured out how the entire process works by the time we get to subcomponents. And the subcomponent test is just a validation of everything that went before. And you do it one time and you're done. And it doesn't always work like that, and so we'll talk about that. So how do we actually assess technology readiness? There's a kind of the industry standard methodology was developed by NASA many years ago, and they made a 9-level scale. So readiness level 1 is, I have an idea, it sounds promising, there's no obvious reason it doesn't work. Let's start on our project. That's kind of level 1. And then you scale up from there through size, through complexity, through integrating details, and you build all the way up. And then when you get to level 9, you have production hardware that you build every day in service, and you know everything works. So that's the scale, and your project will have a readiness level somewhere between 1 and 9. When you put these two together, you put the building block approach, and it kind of roughly correlates to which readiness level you're at. And there's an implicit thought process that you're going to work readiness level 1 tasks first. And when you finish those, you're going to go to level 2 and then 3 and then 4 and kind of work this in a linear fashion. And that isn't always the way things go. And we'll talk about that too and why it is that way. So how do I actually assess, how do I qualify for the next readiness level? So this is an example tool. It comes from the Air Force Research Laboratory. They call it their readiness level calculator. And in this particular example, you're already at readiness level 4, and you want to see if you qualify to TRL 5. And what they do, they ask you 47 questions. And if you get a yes answer to all 47 of these questions, then you are considered to graduate and you can move from level 4 to level 5. And these questions are very thorough. They interrogate every aspect of your project, including the business case. The other point to be made, though, about them is that they are generic and standardized. It's the same list of questions no matter what technology is being developed. And so that standardizes it, but it means that some of the questions won't necessarily apply to your project, whereas others will. It also has the feature of allowing a % complete for each question. So you might, on any given question, you might be 20% or 50% or 80% complete. But the idea is that when you graduate to level 5, you get a 100% yes answer to all 47 of these questions. Now, other organizations probably do it a little differently. This is one example. The Department of Energy, they have, for the same level 5, they have 34 questions. And they are different questions, but they're basically accomplishing the same goal of making you assess your entire project before saying you're ready to move up to level 5. So your characteristics of your current process is, it is standardized. You can use it on any technology. It doesn't tilt the playing field to favor one technology over another technology. So you can do apples to apples comparisons across technologies. It's generic in that the questions you're asking are not customized to your specific project. You're asking the same questions for any project. Now, on this implication of this linear progress through the readiness levels, I do want to kind of point that out. In composites particularly, history is littered with examples where defects didn't come out until you built the large complicated part. And when you get a large part where you're integrating a bunch of features together, defects have a way of popping out. And sometimes you want to build a larger, more complex part early in your program to flesh out what those defects might be. So I'll talk about that a little bit more as we go. Also, you have this very simple metric. Your project is a 3 or a 5 or a 7. It's obviously very easy for the senior manager to understand what that means, but it doesn't really convey a lot of information about the overall project progress and what tasks have been done. And it doesn't point out any specific risk items that you have going forward. Maybe the best thing about it is it forces the project engineer to think through all the details of the project, which is something you don't always do on a day-to-day level. And it does simulate this kind of idealized world. And let me illustrate that. So what I've got on this left half of the page here, left half of the slide, this is your idealized world where I had a project and I worked all the tasks of level 1, then level 2, then level 3, then level 4, and I'm working through level 5. And so I could report this to the senior manager as I am at TRL 4 and it's all good. Everything's perfect, okay? But in this slightly more realistic example on the right, I worked through everything on level 1. I worked through a bunch of the tasks on level 2 and something happened. I had one particular task where the test didn't get done or something broke or something had to be repeated or, for some reason this particular task didn't get done. And then I didn't stop work. I continued on with all these other TRL 3 and 4 tasks. So how do I report the TRL status of this project? Well, per the official protocol, They call it the weakest link assessment. I would have to say that this project is at TRL 1 because I haven't done everything on TRL 2 yet. And so for the lack of this one task, this project gets reported as a 1, whereas this project gets reported as a 4. So that's kind of an ambiguity. It's misleading whichever way you report it. And so that was a feature that I wanted to address with my tool. We'll show that. Secondly, your project is not just one project. You have to apply all aspects of your processing to every feature on the part, and you have to pass every requirement that's in the engineering drawing or in your process specification. And so you're going to have a whole bunch of tasks, and a lot of them probably all work on the first try, but a lot of others require a lot of development. And so you're going to have, for this particular feature of the part, I might only be at readiness level 2 or 3, while in other areas I'm at level 5 or 6. So you've really got a whole bunch of your readiness level that you assign is really an agglomeration of a whole bunch of readiness levels, depending on what it is you have to do on the part. And so there's an ambiguity there that doesn't get reflected in this simple single number of a technology readiness assessment level. So just wrapping up the current method, this is a very difficult task. And as a reflection of that, there are mountains of documents that give guidance on how to do these assessments. And even beyond the assessment itself, it's acknowledged that not only you have to report what you've done, you have to assess the risk of the tasks you have not done yet. And there's a whole other tool for doing that, and it has all its own issues. As a reflection of all of this, and 4 previous studies that had indicated problems, NASA issued a document in 2016 on how to do readiness assessments better. And it reflects a whole bunch of other work, but it's just showing it's all complicated. And even beyond all of that, there are some factions that would argue that technology readiness isn't enough. I have to assess manufacturing, integration, and system readiness. And then you've even got organizational resistance to change, which I've certainly run into, is you bring in a new change to the factory and it will actually work, but the factory folks just prefer the method that they've already got. And so that becomes a challenge in implementing change. So if we're going to have this second page supplemental report to give the senior manager a broader view of what's going on with the project, what does it have to have? It's got to be easily digestible. He's got to be able to look at it in a matter of 30 seconds and understand what the status is of the overall project. It's got to show the progress that reflects the actual customized test parts that you are building with their specific design, processing, and requirements. It's need to show the progress as specific pass and fail to each requirement. It's not subjective judgments of what you think of likelihood of success is. It's got to show what actually passed and what has not passed yet. And it'll also need to reflect the reality. You want to show visibility of the work that's being done at the higher levels as well as the lower levels, so he can see the overall project, not just this single number. And it's got to be flexible enough to adapt and evolve with your project as you get results and as you change the test parts you have to build and possibly change your requirements. So this slide is the template of what you would provide to the senior manager. You're going to provide him this table that will show your various test articles, from the simple ones to the complex ones, and all the requirements and whether they've passed or failed. So scaling level 1 will be flat parts. You have a list of requirements. If I tested it and passed it, it gets a green. If I didn't test it yet, it's left blank. And then in particular, you want to show the red ones are, I have a process that I thought would work. I built this test article and I failed this requirement. So this is telling you the process I thought would work doesn't work. And so by showing these 4 blocks, this focuses the discussion very specifically. Now the senior manager can look at this, and in 5 seconds he can go, okay, what's going on with these 4 red blocks? You know, if your process doesn't work, are we looking at something that fundamentally threatens the project, or are we just looking at something where we've just got to do it a little better next time? And so it shows you all the work that's happening on all the projects and all the requirements, and it focuses you to exactly to what the problem areas are and what needs to be fixed in order for you to move forward confidently. So for the purposes of this paper, I created a hypothetical project to develop a composite wing spar. It's got mechanical properties, it's got processing requirements. There would be a longer list than this in the real thing, but it's got, and specifically, it would have a bunch of part features that make the manufacturing challenging. And so these are what's going to fill in all the requirements in your table that you put in. So in creating the test article scaling levels, this chart illustrates examples of what the scaling levels are and what the requirements would be. So my simplest test articles will be flat panels, and I will have a whole bunch of requirements that those flat panels have to beat. So I have to build them, test them, and they have to all pass 100% of these requirements. You have to pass 100%. So the next scaling level is these basic geometries. I would introduce radii, I would introduce ply drops, I would introduce thick and thin laminate, etc. So you'd have requirements for these basic geometry parts. And then I'd scale up to level 3, 4, 5, 6, 7, and they get progressively larger and integrate more of the actual part features into the test parts that you're building. So, but the one I want to highlight here is this level 5, what I'm calling a large part simulation. This is the one that I'm using as kind of my distant early warning signal to tell me what's likely to fail when I get to a large integrated part. So early on in the program, I'm going to build a fairly large panel that combines the contour, it combines the part features I expect to cause problems, it combines all the tooling features. So I make this complicated part and I build this early in the project. And most likely, the first one that I build will fail. But where it fails will point out to me what kind of test parts I need to be doing at levels 2, 3, and 4. So this is something that I'm going to build as a large part early in the program to tell me what's likely to fail, to give me more likelihood of success, so that by the time I get to my subcomponent and component levels, I have confidence that everything works. So this slide is kind of the centerpiece of my presentation. This is the report, an example of the report that you would give to your senior manager midway through your project when you're reporting what readiness level you're at. So again, it similarly, it shows the scaling levels from flat panels, and I've passed 11 out of 12 requirements, and fatigue isn't done yet because that requires months of cycling. And then I've got contoured panels. I've got some panels to simulate the thick end of the part because I expect problems there. I've got a twist section of the part, etc. So these scaling levels go up in complexity. So first of all, senior manager looks at this, he sees, okay, I've got work going on in all these different levels. So he understands a whole lot more about the complexity of the project than what he did from just hearing I'm at technology readiness level 3 or 4 or 5. He sees which tests are not done, and that gets a little bit of his attention, but it focuses him particularly, and he's going to look at this, and immediately he's going to say, wait a minute, you know, in the twist section of the part, you cannot get the part off the mold. What's going on with that? You've got this problem in the spar twist section. You've got ply waviness. You've got unacceptable laminate quality on your simulated part. So you can have now a short, focused discussion directly on the issues that are really risking your entire project. And it just gives them a much broader perspective on what the whole project is all about and what the true status really is. So my last technical slide is just showing the adaptability of the slide, kind of based on a couple of the failures we had on the previous slide. In this case, the project manager decided he had two new columns to the table. He added a designed experiment to address the ply waviness problem. He inserted, there will be panels that you build, there will be requirements for those panels. And in this case, you've tested them, you passed them, you solve this, and so you move forward. And similarly, you do some cure cycle modifications to address the specific areas of your part that you didn't get acceptable laminate quality, and you go for it. So this is just illustrating how you can add additional columns to show more test parts, or you can add new requirements as you decide that you need them, so that the tool can evolve as you go through your project. So summarizing everything, the industry standard readiness assessment methodology is something that we have to have. The senior managers need it to plan for the future, but it does have limitations in terms of the information that it does provide. You don't get a full assessment of what the project is really about. So this paper proposes this one-page addendum report to add some of that detail, but make it something that a senior manager could understand in a matter of seconds. It tracks the work by the actual test parts that you're building, not generic concepts of what technology advancement is. You reflect the specific designs, processes, and requirements in your test parts that you are building that will lead to your part. It does reflect the reality that you will be working on large parts and small parts, and it shows visibility of all of that on one chart that you can read instantly. And it does give you this progress is shown in a binary method. You pass or you fail. You don't subjectively report whether I think I'm going to pass or whether I think I'm going to fail. It's pass or fail. And it's adaptable as the project matures. You can add more requirements. You can add more test articles if you need to. So the report can evolve as your project evolves. So again, thank you all for coming today. I hope you enjoyed the presentation. If there is interest in discussing any of this or further communication, I would be happy to provide that. Hope you're all doing okay. Stay safe. Take care, everybody. Thank you.